Hello everyone. A warm welcome to everyone. So here we start something new. This is from Navalt. My name is Ajay, and I'm the business development head of the company. And we are here to present something new. So we understand that there is a very big boom in the electric market, and the modern application is like going like anything. But at the same time, we also want to make sure that everyone is aware about all the things that we have in this industry because it's a very new one and very fast growing. We have a lot of people in the industry who is actually experts in this one and will be helping out in getting all the informations that we need. So this is our webinar. We are getting into the public. This is deep dive, and here in the webinar, we will be taking one topic one at a time. And this time, we have taken a very important topic, which is the battery safety. And when we are talking about battery safety, we definitely need people who are from the industry, who are from the regulatory industries as well, and also from the boatyard perspective or shipyard perspective also. So we have here Mr. Sandith, Mr. Martin, and Mr. Srinivasan. I welcome everyone to the stage, and I think everyone is ready to present their piece of knowledge to the stage and get everyone informed and aware about this new technology and about majorly about the battery safety. And we will be specifically speaking about the battery safety in the marine applications and transportations. So, Sandith sir, over to you now.
Yeah. Okay. I have just selected my file. Okay. All right. So just briefly about Navalt. So we focus on solar electric boats and systems for solar electric boats, and our focus today, as Ajay mentioned, is on batteries. And we are trying to share our experience of building battery systems, building solar electric boats, operating and maintaining these systems. Now, the oldest one is more than 7 years. So, we are trying to share some of the insights, hopefully, beyond the regulations based on this experience. So, first aspect we all want to know is why the battery safety is important. So these are three examples of incidents that have happened in the recent past. Two of them are boats, and one of them is large vessel, large battery installation. So in the first case, for example, the Yetrio N, and this was a coolant leak, short circuit, thermal runaway of the modules. The second one is of Tesla, and even such a very reputed big battery maker can also have such failures. Two of their container battery caught fire out of about 200 of them, which is about 300 megawatt hour installation, massive one. The third one is MS Bren. Again, this was seawater ingress through a ventilator, leading to short circuit, electric arc, and fire. So all three accidents coincidentally are all on NMC, NCA chemistries, which are relatively unstable compared to LFP or LTO. Now, when you come to battery, when you come to boats, if you take overall two aspects, one is the boat accept system, and what we mean by system is the energy production, storage, and usage. So the basic structure of the boat, ACP, interior, accommodation, all that is boat, which is common to any kind of boats. The system is where all related to electric things change, and that's how we group it like this. Now, in a boat or in any vessel, there could be five sources of energy, which is grid, stored in battery, the solar, wind. Again, wind could be wind to thrust or electric, any kind of fuel cell. It's not just hydrogen, any kind of fuel cell, and any kind of engine that burns diesel, HFO, whatever clean, even clean fuel. So these are five types of energy sources, and even the combination of that is the smaller boats. Largely, it can be battery and solar. When it comes to the medium size, the battery contribution reduces, and in the larger vessel, battery contribution is almost insignificant. So this is just a context on the usage of this energy. And here, since the focus is battery, we will try to lay out the energy source, which is either propulsion or auxiliary. And that's basic layout is shown here on all these five energy sources, how it can contribute to auxiliary and how it can contribute to propulsion. When you're selecting, what we are trying to do is two things. One is the choice of chemistry, and second is the sizing of the battery. And both are interrelated, which has to be done in parallel. Based on the safety aspect is one, and second is to meet the functional need, which could be speed, range, or various other things. Now, from the safety of battery, if you see broadly, this captures all the possible issues in a battery, whether it is on a cell level, which is like a list of items from a cell manufacturer level, is it? And then it could also be on a module level or a system level. And then the main things are all related to controlling in the operation level. So all the possible issues from a safety angle are listed in this chart, and our objective is to address everything by various regulation and various operational practices. Now, from a chemistry, if you talk about chemistry, there are again, of course, within battery itself, whether it's lead acid, nickel cadmium, or lithium. So lithium is the obvious choice because it does have a lot of characteristics which are favorable for a transport application. And within lithium, there are again many different chemistries. So in an auto industry, for example, there are certain parameters like weight to or energy to weight ratio, etc., which may not be so crucial in the boat industry. So what parameters you use to weigh this is also important. In the boat, the sensitivity to the battery weight is less. So in a car, for example, 40 to 50% is the weight of the battery, whereas in a boat, it is less than 10%. So which means many of those parameters are not important. What is important then becomes the safety and performance. And within this, if you rank these parameters, it turns out that LTO and LFP are relatively much more safer and also gives a performance also. So when you see performance in application where you need fast charging and frequent charging, it is more towards LTO. And when you need a relatively slow charging or you design the system for whole day, you do an LFP. This is pretty clear when the range and the speed are very wide. But in certain application, the decision is a bit more trickier, and then you then have to do also the economic factor. So which is the other element of decision on whether to do an LFP or an LTO. You need to do an economic analysis beyond the safety or performance, because you can either have a smaller LTO battery to meet the performance, or you can have a large LFP battery to meet the same performance factor. So this is an example of a 100 passenger ferry where when you observe that as the speeds and range increases, the LTO chemistry becomes more attractive. Whereas when the speeds and range are lower, like 8 knots, 10 knots, or less than 100 kilometers, it is LFP that is attractive. So this is a very important analysis, because many a times, at least there are two examples I can see where this has not been followed well. The case of KMRL or West Bengal ferry is an example where the choice of chemistry, which is LTO, has led to the boat being almost twice as expensive as what it could have been if it was done in LFP. Now, coming to the various tests, which I'm sure class Mr. Srinivas, who is expert in this, in the regulation, will list more in given detail. But I'm just telling there are three levels we need to take care of the safety and test. One is on a very cell level, and then there is you do on a, and then the selection of BMS. Obviously, BMS have a lot of important function. Here again, I just want to reiterate that BMS, even for a small battery, the cost range, it could be as simple as 5,000 to 50,000, 1 lakh. So there's a huge range in BMS cost, and the choice is so important in terms of taking care of all the safety aspects. Then the system side, again, there are a lot of tests from an IEC level, the environmental tests, safety, performance, etc. Again, the next two speakers are expert in that. They will talk on that. Some aspects, like from our practices, I'm just trying to add on. There is, of course, class requirement on ventilation, etc. and there is the class requirement for gas detection based on chemistries. But our practice is try to position the gas detection inside the battery itself. So more or less where the exhaust side is, because that is more quicker to detect rather than the whole compartment. This is just our experience. Again, the additional sensors like detecting whether the battery is itself bulging, like pressure sensors, and then temperature sensor inside the box, as well as on the bus bar. These are certain things by practice we are also doing. There is, of course, fire protection requirement from the class side, whether it is A60 insulation on the battery room itself, or the fixed systems and portable systems, etc. In addition to all these class requirements, there are certain things we do again based on our experience. One is we try to put all these alarms and safety things into three groups. One group of information is like you are aware that something is going to happen, which I say is more of an information level one. The second is which causes a slowdown in the system, like the motor is forced to slow down because of some parameter is breached, like for example, the motor current, motor temperature, etc. The third one is like shutdown. So you're forcing down the system shutdown. If it is on the load side, for example, if the motor has an issue, this is important compared to an EV. The propulsion can be cut down, but the auxiliary still has to run in the boats, especially. That is important. But in, let's say, EV like auto rickshaw, you don't care, you shut down the whole thing down. So there's just one important difference from an operation. Again, in a solar plant, because most of our boats have large solar plant, typically the MPPT side protection is decided on the pack voltage level. So that is how they decide a cut in, cut out. Whereas if there is a communication between the BMS and MPPT, so which means there is a one layer of vessel control unit required. So if there is a communication, even if the individual cell level has slightly higher voltage than the prescribed limit, you can force a shutdown of the solar plant itself. So that's something additional we tend to do. We also by practice tend to avoid solar or make solar charging only in the bulk mode. So the last segment of the 95% of the battery, we don't do solar charging because then the battery balancing is more trickier if you disable the BMS balancing. So only shore charging is done on the last level of charging. Then again, shore charger, another important thing is almost always the shore charger should have this communication, CAN-based communication with the BMS, so that any issue from a BMS side, this has to be cut off. But even if the CAN cable has or communication is lost, also the charger has to be shut down. This again, something what we do in practice. We also have all our batteries typically having remote monitoring, including cell level monitoring. One to monitor on a online basis, plus also do certain analysis. This helps doing this quarterly inspection as merely simple physical checks, and rest all is done online. So this is remote monitoring is again a very important thing in the battery safety. So all these practices what we have been doing is what I say as Aditya running now 7+ years, with about 2.2 million passengers have been served, is a tribute to what we have been following in all our systems. This is just an example, and we feel that this is the way to ensure the safety of solar electric boats and its wider adoption. Thank you very much.
Thank you so much, sir. And I think that was a wonderful brief on, let's say, at the start of this session and also the start of our webinar deep dive. And I think, as I rightly mentioned, we have the expertise, Mr. Sir, Srinivas sir, and Mr. Martin, who will be taking up on their respective topics. So, Srinivas sir, I welcome you. Before that, I'll give you everyone a small intro about Srinivas sir. So the veteran here has a 41 years of experience in maritime industry, and I think his experience is spanning from design and consultancies, and also he specializes in control automation systems, maritime cyber risk. And I think he's into something that everyone is maybe scared of, and also very risky job, and also very responsible. As we say, with more power comes more responsibilities. So now, sir, he is in the Department of Electrical Control Systems, and he is heading the department in IRS. So, sir, over to you now. Let us hope that you are able to get all the information that you have in you, so that we are also aware about the specifications and other criteria which makes battery more safer in terms and in the perspective of IRS and the department. Over to you, sir. Thank you.
Thank you, Mr. Ajay. Thanks for the kind introduction. So just try to put my presentation. Okay, it's already there. Fine. I can navigate this. Huh? Should be able to. Okay,
Yeah.
excellent. Huh? So good morning and good afternoon to everyone. So we just before because normally when you say the class comes, people are always thinking, why do you want so many documents? Why all those things? So the normal point of interaction, first interaction is that one. So I thought, why before we say what documents we want or what kind of testing we do, let us run through what is the basic objective of asking all those things. So basically, the main objective is to ensure that operation reliability and the safety of the system. So the main fundamental criteria for going ahead is funding. Second, ensure that all the hazards which are associated with battery systems are assessed properly, systematically, in a structured manner, and proper measures are taken to mitigate them or at least to minimize them. See, sometimes it is possible to totally mitigate them. Sometimes you may have to leave it, but bring the risk level to level down so that they are safe to operate. And we need to control and monitoring systems to know the state. What Mr. Sandith has just told us, the various levels of alarms, 1, 2, 3, and all. And same time, not only monitoring, we need to take action also sometimes when the things go out of the hand. So need a shutdown systems there. And depending on the type of the vessel and where it's operating and what class rules it is following, because we have different kinds of rules for inland navigation, rules for mean sea going, different types of rules. So we need to, or passenger ship, obviously these are passenger ships. So we need to consider what kind of redundancy we need. See, when you say look at the safety, the first column, what you have seen, the safety we are talking from the perspective of the equipment. The last column, the redundancy comes because of safety of the vessel itself, where it's flying. Anything happening to one of the equipment or systems, still you should be able to safely navigate and come to nearest shore. So, considering the safety, redundancy is one of the aspects. With these objectives in mind, then the design, whatever is developed, has to address certain basic things. I have not elaborated it because it becomes very difficult in the short span of time, but broadly, the short circuit, which is one of the most critical things, electrical circuits, the overcurrents, the voltages, because these cells, we are not getting into much of theory, but charging the cells, there is a voltage levels are becoming very important. So over and under voltage and thermal runaway. That is a thing Mr. Sandith has shown in the very first slide, where three vessels examples he has shown. And thermal runaway has become one of the most talked, discussed, maybe less understood topic. And thermal runaway basically, like any other fire, which require three ingredients, like any fire you talk about. Basically, it's an uncontrolled fire, thermal runaway. Three ingredients. One is oxygen, the fuel, and the heat. It is true for not only battery fire, any fire. But in case of battery, what happens, or let us come to normal fire, the idea is to minimize these three things and the chain reaction, which is the fire itself, how to stop it. So in case of battery fire, the battery is like a fuel itself. And because of the inherent design and chemistry, it is able to generate its own oxygen. So that means you are left with only one thing, that is the heat. You have to control the heat and break the chain reaction. Heat control, so what we are doing is thermal cooling, ventilation, all those things coming in the heat when you are trying to control the heat part, and fire extinguishing systems, which we are trying to break the chain so that fire is still extinguished. This is how we try to achieve, because first two things are not in the control, the design of the system. Of course, as Ms. Sandith has said, if you are using a different kind of chemistry, then of course the risks are comparatively lesser or more depending on the chemistry used. But fortunately, unfortunately, what we have seen in the so far in battery systems, the maximum case of thermal runaway, as he has already said, is NMC. So we started something with one chemistry where there are a lot of mishaps have happened, and the general fear has set in that lithium and batteries there is a risk. Risk is there, but sometimes because of the particular chemistry, if you look at other chemistries, LFP and LTO, they're compatible lesser. But since this forum is not to discuss too much on chemistries, but they are less when the gas involvement is less. So those things do matter. The time of kind of chemistry you select. Then comes external fire. Why external fire is important? Like any other fire, but in case of battery is more important because it is also a source of heat. So even internally the heat is not produced, the external heat can itself cause the damage. And since it has to sit in the environment, maybe outside or vibrations, shock, so many issues are there. So we have to design has to address the environmental aspects also. Now, to ensure that these things are done properly, or at least to verify that they have been addressed, we have our scope. We start from the looking at the product certificates of the battery modules, the BMS, that is battery management system, because to prevent this kind of overheating, undercharging, overcharging of all these things, a proper BMS is very essential. So the BMS becomes one of the most important safety factor, not only for the perspective of charging the batteries, but maintaining the safety of it. So when we look at those BMS and modules, we make sure that they're designed and tested as per standards, and their vessel specific documents are tested. These are the product certificates, what we talked about. What is the basic functional description, why it is intended, where you want to apply, what is the area of operation, that becomes very important. If you are a sea-going ship or a small boat crossing just a ferry, as acting as a ferry crossing a river, this risk assessment becomes an important factor. And what are the installation plans, where you're installing the batteries, the firefighting systems, cooling systems, and the test procedures. And once these documents are assessed, then we got on to the survey of the installation and ensure the satisfactory compliance of the functionality through harbor acceptance, sea acceptance trials. And of course, we have a system when the vessel is classed with us, we carry out a periodical and subsequent surveys also. So when you talk about risk assessment, and one of the most important document apart from this is the loading fact, the load analysis. Because depending on the vessel, how much the battery has to be sizing. The battery sizing becomes very important. Whether we need 100% redundancy, it has to operate 80%. What is the frequency of charging? Because if you're crossing just a ferry, a river, then if you are there in 15 to 20 minutes of time, and you have a procedure, you have a facility to charge the battery on the other side, then the capacity of the ampere of capacity of the batteries can be suitably sized. But if you don't have a facility and you have to come back after 5 to 6 trips, then they're different ball altogether. So the availability of charging facilities at the shore and the voyage duration makes it very, very important to calculate the battery capacity. And obviously, to these kind of ships, especially when you're talking about small boats, which is the battery capacity matters a lot, not only from the cost point of view, the space and the weight. There's two important things: the space and the weight. The bigger the battery, that in a small boat of 10 meters, even keeping a bigger battery is a challenge by itself. So need to have optimize the battery, same time making very sure that your safety of the operations is maintained. So these are one important document we assess, ensure the operability, the operation time, the number of trips per day, and charging facilities, so that batteries are optimally sized and safety is taken care. Once we have considered the battery sizing, ensure that all the standards are met, the next thing comes the installation part, especially the battery space itself, or the battery room, the battery space. We should have some means of detect any fire or jetting in the battery space. It could be outside batteries, not inside the battery itself. It can be in the battery room due to some other cause, or inside the battery. And we should have a proper safety equipment, fire safety equipment. And that's a fire equipment, whatever is designed for mitigating the fire, extinguishing the fire is to be suitable for the chemistry. That's very important. So it is not that dogmatic, we may say water based, but it is very important that manufacturer is consultant as to what kind of battery chemistry is there and which kind of extinguisher system is suitable for that. And we already discussed about making the A60 structural integrity so that in case of a fire or thermal runaway, it is contained in the room itself. Why you maintain structural integrity? Because you want to contain the fire. You want to prevent the fire. Now, not able to prevent, at least contain the fire so it doesn't go out the room. And we should have sufficient cooling and ventilation systems so that operational systems is maintained efficiently. Next, we talk about the BMS, which we said the heart of the whole battery management system is the heart of the BMS battery system itself. Why it is required? Normally, we have battery chargers for normal ships, normal batteries. Their role was just limited to charging the batteries. But here is not only charging the batteries and the cells, but the condition, the overheating or the temperature, all these aspects are controlled by the BMS. In the unsafe situations, it detects inside the battery itself and is able to trip the battery system as appropriate. It is able to monitor the state of charge and state of health. There's how much charge is left so that, and these things are displayed in the bridge or wherever the manned station is there. So the operator knows what is the state of charge, when he has going to charge. So he's an indication like the fuel, how much fuel is left in your gas tanks. And we need to protect the voltage and current protections. Of course, thermal management, as we just discussed, is very important. So it always keeps track of the temperature of the cells, a particular cell or in the module, and takes appropriate actions. Apart from start and stop, because any unforeseen things can happen, we need emergency shutdowns. Those shutdowns can be automatic because they're based on temperature or gas retardation systems, or could be manual, which is located just outside the battery room, and in case of some of the ships where it is also required in the bridge or other control stations. And this point we discussed, the battery management should be able to monitor the voltage and currents, high resolution, and communication. So it is be always the BMS needs to communicate. It has to be integrated with a weather power system, because if you have a normal, apart from the batteries is in a hybrid mode you're operating, then there could be other generators and MSB powering up. So when to switch on the batteries, when to switch off, how the load sharing has to be done, these are where the main power management or energy management system takes care in the main switchboard. And the battery BMS has to communicate through the to MSB for these issues. And the test, what we have Sandith said, basically we can talk about tests in two broad categories. First of all, one is cell level, one at the system level, battery module level. Cell level is short circuits, the impact and drop test, thermal abuse in case of the external heat, overcharging and forced discharge. So for all the things, the IEC has clearly given a guidelines, what are the thresholds that cell has to withstand. Once the cells are procured, most generally from the different manufacturers and assembled into a module level, again the module has to undergo certain test. One of the important tests is propagation. That is, in case there is a short, that means we are physically trying to create a thermal runaway. In case the internal short, at the cell level it is tested. At the block level we have to see it doesn't propagate to the adjacent cell. Or there could be a situation we want to test module to module also. Then one module is on the fire or thermal runaway, it doesn't propagate to other module. This test is not a compulsion, it could be a case specific, but there are some guidelines coming out at later stage. And other tests are overcharge with voltage, with the overcharging with current, heating, and capacity validation, more of an interest for the ship owner. Make sure that whatever the manufacturer claims, it indeed delivers. And the insulation testing and pressure testing. Sometimes, most of nowadays, you have a cooling system, maybe external cooling system. cooled with the water or ionized water, the cooling system may need to be tested. And if you use a high pressure, the pressure testing is to be carried out. Apart from these two tests, at the block level, we need some environmental tests also. These, as per the one more standard 62620, discharge performances, internal resistance, endurance. That is how much this is designed for. There are some graphs are available in the net where they say the life cycles, how much it can withstand. So more number of cycles will run through. The battery itself, the life of the battery also comes down. And in case the battery is used as a emergency storage, emergency power supply, you need to store for longer times before it really comes to action. So you may not be charging and discharging it very frequently as normal battery. So whatever charge you are given should retain. So that last test comes in handy there. How much is able to store? What is the drop in the long run if you're not using for day, 2 days, 3 days, whatever. And all the last but one slide, that audible or visual alarms are required in case of anything going wrong. As Sandith said, the various levels are there. What we are trying to monitor is the protected devices. Whenever the protected device operates, it should be known. Alarm should be given. Individual cell temperatures are high. The battery space temperature itself is high. The ventilation fan is not running, or if it is AC cooled, the AC system not running. Voltage is cell, and of course gas detection, very important, because gas, this is one of the most important factors which sets, even gives the first indication something is going wrong. Because look at the battery fires, there are different levels. When some forums have discussed it, the earlier signs is there's the involvement of gas whenever there is a internal fault. So if you are able to detect the gas, any gas in the outlet, then immediately apply the cooling or cut off the system. You can cool it down. The next level, it has reached a stage where the whole concentration will be how to put the fire off, than how to mitigate it. So that's how it is. That's all from mine. Thank you, Sandith. Thank you, Ajay.
Thank you so much, sir. I mean, we are now with overloaded with too much information, and I think Sandhu sir is taking the notes to keep the battery and all checked. And I think it was a wonderful session, very informative. I think Sandhu sir is waiting to say something about the session, sir. Sir, yeah, you're on
We'll,
mute.
we'll wait for Martin also, and then
Okay, sure, no problem. So, yeah, thank you so much, Shrimya sir. Now on to Martin. So I think we have Martin here. Say hi, Martin. If you can see us, because Martin has been too serious about the presentation. I was saying he was into the thing and was waiting for his chance to get all the things to the stage. So I'll speak something about Martin. He has a great experience in terms of battery testing, certifications, and regulations. And I think after serving a good amount of years in different companies of battery manufacturing and other industries, he has started M Lab testing, which is his own firm, and that's specializing in regulations under UN 38.3 and other marine regulations, rules and regulations. And I think he will be the best person to talk about testing, which is actually a very important thing in the battery, as we all know. So, Martin, the stage is all yours now. Please take over.
Thank you very much. I hope you can clearly understand me. Let me open the slides. So yes, very shortly, I'm Maarten Mooi. I'm the owner, founder of MLab Testing. We test lithium batteries, and we started the company because there was a gray area between certification bodies who are very good in providing certificates and what manufacturers and producers of lithium batteries and systems would like to have tested and need support with their risk analysis. Because in the end, it all comes down to do a proper risk analysis. My focus for this presentation, I only have 20 minutes. I can keep talking for days about certifications and testing and information about batteries and systems. So I have to try to keep it very short. So the certification process itself is it's an important topic. So what happens? depending on if you're a producer of lithium batteries or systems, or maybe you are even a producer of fully electric boats or vessels. And what happens is that you are building a product, and at the moment you are building a product and you want to put it in the market or you want to sell it, then you need to show the product is safe, and you have to make a proper risk analysis. But that's very general, of course, because who determines what is safe, what is not safe, and how are you going to evaluate it? Luckily, we have lots of rules, regulations, standards, norms, any kinds of documents, etc., which can help you with it. So as we focus today specifically on the marine industry, there you are dealing with the following situation, is that when you're building a boat or a vessel, whether or not you're making it electric, yes or no, you have to show the boat is also safe. And you have to register your ship, your boat, your vessel, basically to the national authorities by saying, I have a boat and I want to place it on the water and to use it for commercial purposes. At that moment, the national authorities has to approve your ship, but they don't have the main capacity and the knowledge themselves. So they are being supported by class societies, and those inspectors will do actually the full inspection of your vessel. And it concerns the entire inspection of a vessel. So it's not only the battery itself. No, they will take a look to everything that's related to the vessel and if it keeps floating on the water, yes or no. In this case, it helps as a producer, because we are focusing on the electric vessels, is when you're producing the lithium batteries, because they are mainly lithium. If you're producing lithium batteries, you want to have your batteries installed on such a boat or a vessel, meaning you have to comply with the rules and regulations as being laid down by either a class society or a law which we have in Europe, which is called the ESTRIN. So what happens, you have to apply for it, you have to register your boat, you have to open a project with the class society, and at that moment you have to provide documents which shows compliance with all the rules that they have. If you don't have it yet, there's a large document, it's a big standard, telling you what exactly you need to do and how to show this compliance. Most testing has to be done at an ISO 17025 accredited laboratory, or the testing is being witnessed by the class inspector. So they'll come to visit you or another laboratory and they say, okay, show me the test, show me how you're going to test it, show me the function, that everything works properly during the test. And if that's okay, please issue the report and we will provide a stamp on it and we'll accept it in this specific type approval. So that vessel is okay. But that also means that if you're delivering to another vessel, you might have to redo the testing and again have everything witnessed. So it's not a full type approval certificate which you will get in this way. Typically, the type approval itself can take time up to 2 years to get it. Of course, this can be faster as well, but you need to be very well prepared. If you're going for a type approval certificate with any class society, and you are not prepared because you just built a battery pack and you say, I want to have a type approved, you need to provide really a lot of documentation, showing everything from electrical schematics and drawings up to test reports containing all the information. And that's a lot of work and takes a lot of time. On the other hand, in Europe, and I will go a bit deeper in detail on the next slide, is we have the ESTRIN. The ESTRIN works a bit in the same way, but the difference is that the class societies, they are partially responsible for the technical, how to say it, the technical condition of the vessel. ESTRIN is a European law. So the inspection, if you are meeting the requirements from ESTRIN, can be done by a class society, but it can also be done by another inspection body. And because it's a law, it means that for every party who want to comply with ESTRIN, the same rules will apply. And this is also a bit different from class societies who have their own set of documentation and rules, and they can differ from each other. So if we look to the ESTRIN, that's short for European Standard, laying down technical requirements for inland navigation vessels. And this is a combination. We have a directive, which is a set of rules, setting targets to which your product has to meet. Basically, also the vessel has to meet, but they are not telling you exactly how to do it, compared to a law which is also dictating you how to do it. And this directive, what we have, the 2016-1629, is a bit combined together with the Rhine vessel inspection regulations from the CCNR. And the CCNR is the Central Commission of Navigation Vessels on the Rhine, which is a river flowing through Europe, from Switzerland, going through Germany, France, and the Netherlands. And they both refer to the ESTRIN, and those have the core technical requirement for inland navigation vessels. So this is applicable for an entire vessel. So what we do, the tests which I described, and as I specifically focus on the electronic products, or specifically also on lithium batteries, the ESTRIN is dictating a few tests to be performed. So first of all, there are specific requirements on certain EMC tests. These is an ESD test, radiated immunity test, and an EFD test. So with the ESD test, we have a small gun, and you apply a few kilovolts on your product, like you're charged, or there's another product being charged for whichever reason, and you will discharge your energy basically to the product, and your product has to remain safe about this. And this voltage can go up to a few kilovolts. Then we have the radiated immunity test, and this radiated immunity test means your product has to be able to withstand interference signals coming from the environment where it's being used in. So there are a lot of electronic equipment surrounding your product, and they cause electromagnetic interferences, and your product has to be immune for those interferences and should operate properly in this specific environment. And then last one, we have an EFT test, which is electrical fast transients. And those are basically high voltage peaks, which can exist on specifically power lines or communication lines coming into your product. And again, your product has to be immune for these kinds of interferences. So these three tests are mainly focused on immunity, which is actually very good. But we should not be mistaken that also there's a specific requirement on EMC in the ESTRIN, which basically says your equipment is not allowed to have a high emission, disturb other appliances, and it should also function within the environment your product is being used in. Next to this, which is almost similar to the class society's rules, is there are some environmental tests. The ones in the ESTRIN is a heat test, going up to plus 55 degrees for a few hours, and your product still has to show it can function properly in these high temperatures. Then there's a cold test, also depending on the location of where your product is being placed, and also your product has to withstand low temperatures, and during these low temperatures, your product still has to function properly. And there's a vibration test mentioned. And this vibration test, the heat test, cold test, and vibration test, they are almost identical to the tests from the class societies as well. So I hope there could be a mutual recognition of the test results, but it would be a question for later on. The vibration test is very simple. The product is placed on a vibrating table, and at the moment we are going to measure if there is a resonance frequency somewhere on the components. Can be on PCB level, can be on high or heavy components, can be a bit on not really on cabling, but it can be on critical electrical components. We perform a sine sweep test, and at the moment we measure a resonance frequency. We have to annoy the product on this specific frequency and to see if it lasts for a certain amount of time and it will not break down. So what you see is that these general tests, the environmental test and EMC test, are all based to check whether your product remains functional during the expected conditions it will be used in. And then there's a specific requirement about batteries, and this is where it gets a little bit different from the rules from class societies, is that the battery itself must comply with both EN 62619 standard and EN 62620 standard. And they have to comply fully with this. And that can be a challenge, specifically the EN 62619. This standard is divided in a few parts. So there's a general assembly part, because you assemble a battery from specific components like the BMS, cabling, terminals, insulation, enclosure, etc. This all compiles your battery. And the standard is having requirements on all these aspects. So one of them is the cell tests themselves. So there are a few tests that need to be done on cell level, and most of them already also mentioned before. We have an external short circuit test, there's an impact test, a drop test, thermal abuse test, overcharge test, and a forced discharge test on cell level. Next to it, there are requirements in the standard about a propagation test. And this is where it becomes a bit strange in the specific standard. It seems the standard is giving you an option what to do. Either you perform a so-called internal short circuit test on cell level. This is a test where the cell will be opened. There will be a small nickel particle inserted in the cell, and then the cell will be folded back together, put under a press, and then press this nickel particle. The idea is that there will be an internal short circuit between the positive and the negative materials through the separator, and this short circuit should not cause a thermal runaway of the cell itself. But this is on cell level. The other test, there's an option. There's also a possibility to do the propagation test on the module level, and this is where you deliberately put a cell in thermal runaway conditions, either by nil penetration or overcharging, or maybe via laser to heat it up, or you can use heating pads. And to get this single cell in a thermal runaway, and there will be a requirement that the result should not lead to either fire or explosion outside of the battery enclosure, and the battery enclosure itself should remain intact, should not have any ruptures on the outside, so that you can reach to other like chemical materials. If we compare this test to the tests from the class societies, this test is actually a little bit easier, because this test is performed at ambient temperatures around 25 degrees, and it's only performed on one module only, whereas the class societies are requiring this test to be performed on 3 modules with similar results, and also at the highest operating temperature, which is usually around plus 55 degrees Celsius, and then perform the test. Next to the propagation test, because in my opinion, these are relative easy tests, because you can test it and it passes yes or no. So it's very basic. You do the test, and if the result is okay, then you pass it and you have a nice test report. In addition, there are a few BMS tests. There are only 3 of them, which are relatively simple. These are overcharge test of voltage. So we apply a higher voltage on the battery terminals, and the BMS has to stop the charging process. And we apply an overcurrent test, where we apply higher currents than rated for the battery. And at that moment, when the BMS detects a too high current, it needs to shut down the charging process as well. And then there's an overheating test, where we put the battery in a climate chamber. We heat up the battery above its rated temperature where it can operate in. And in this case, also the BMS has to detect this high temperature and sends out an alarm to stop functioning at this temperature. So this all comes down with the battery. As said in the very beginning, a battery, what is important to measure? This is voltage, current, and temperature. These are the 3 most important parts to measure. But there's a catch in the EN 62619. And this is a functional safety evaluation. And this is a very, very underestimated part of the standard, because the functional safety analysis is required for the ESTRIN, because it asks for full compliance with the 62619 standard. But this test is not required specifically by the class societies. And this is where it goes wrong in many cases, which I also will show in another slide. This evaluation for functional safety is very time consuming. And if you did not take into account functional safety evaluations from the beginning of the development of the BMS, you will not make the requirements. It's not that simple. So you cannot get it done properly with just thinking very logically and thinking safety in your mind. It's not so easy as that. You need a lot of documentation. Also for the software and the hardware will both be evaluated. So this is something that should not be underestimated on what to do. So as we are a testing facility as well, and there are other testing facilities, for sure, we also see stuff going wrong sometimes. And so, next slide. What are the typical failures that we see? So most products, they will fail on the EMC tests and mainly on the communication ports. Because the terminals, the plus and the minus, yes, that's easy, big cables, and they are connected directly to the cells, and the BMS is not really very influenced by disturbances based on these cables coming in. The problem is that the communication ports usually use a CON connection, which is very low voltage. So you can imagine what happens if you disturb higher voltage levels on CON communication. So usually the communication fails. Second problem, not directly battery related, there are inverters being used for AC/DC. The problem is they have a very high noise emission level. This is causing also very big problems also for the BMS. If you have disturbances on your BMS on a vessel, this could very well be because there are inverters very close to your BMS and they are disturbed by these high noise emissions. And the other problem what we see is you don't have the full EN 62619 compliance, so you cannot meet the requirements for the STRIN. So what are the typical challenges as the last slide to wrap it up a bit? The most ISO 17025 bodies, notified bodies or certification bodies, they have very little test capacity. They are very busy. You have very long waiting times before you can even start a project. Take this in account. If you contact a testing agency, they can have very long delivery times before they start a project. Secondly, there are high costs involved. The class societies can be very expensive. You need to have witness testing maybe done. You have to pay the inspector. Those have also quite relative high hourly rates. The testing costs are also expensive, and then you're not there yet. So you still have to do, maybe you have to do some redesigning. Maybe you fail with a certain test. This is something you don't want. Testing in advance gives you a really big advantage at the end of the line. And that all leads to very long delivery times. So it's not very uncommon that type approvals or getting compliance for marine industry can take 1 up to 2 years time before your product is finally safe and being approved. So this was my presentation. Very shortly, because I have a lot of other things to tell, but we have to stick a bit to the timing. So I hope it was informative and useful at the moment. Thank you very much.
Thank you so much, Martin. Thank you. I mean, what would I say? I'm really sorry, but we do have the time constraint. But it doesn't feel like we want to stop it. But like I mentioned, we do have some time constraint. And I can see there are a lot of people who are grabbing their keyboards and asking a lot of questions. And I think that they want all the answers right now itself. And I think a lot of questions are coming in. Maybe Sandith sir, your input on this as well. It's very important.
Yeah.
I think people are getting frustrated right now to answer their questions.
Okay, sure. So I will. A lot of questions already popped up, so I will try to group them into some logical topic wise. So as much as possible. So there is. I'm just taking on what Srinivasji mentioned on the NMC and chemistry side. No, so I just want to know. Obviously, class don't have a preference. I understand that, But nevertheless, considering the incidents we know and the fact on the difference in chemistries and its safety, um, the rules are still very goal based. That is good, but many of these tests are always under ideal condition, right? So in the real world scenario, things may be slightly different. So how do you factor this chemistry choice and the differences in the inherent chemistry safety from a class side, Srinathji?
Thank you, Sandith. As a class, we don't dictate any chemistry because it is entirely up to the owner choice. We given some feedback with the yard who are knowledgeable like your company, but we don't have. But when we see a type of chemistry, then we enter as a up. Then we start looking at this risk part more closely and the mitigation parts. See, if you see like fuels, like if you take a normal fuel, any other fuel, you have different rules or at least additional rules like you have gasoline or methanol, ammonia, hydrogen, be all are fuels, but you have a basic rules for the normal fuel. Then as you go on increasing other fuels, depending on the corrosivity, how to handle them, the risk goes up. But so far, any guidelines or regulations which have come out or come out of the battery as a whole, where the distinction between different chemistries has not been made. Maybe is my individual thought process. I'm not saying it's a class perspective, but a time has to come when you need to have a more stringent or more kind of additional measures if you have a particular chemistry. Just like suppose I have a hydrogen, you have a LNG. How do you treat them differently? We don't have. So that is one way I think, but indirectly now as of today, we don't have any rules for separate rules, but we look at this part more clearly, more accurately, and see that all the measures are, and of course we keep learning also with all the is happening. But as I said in my slide also, most of the cases, what case studies happen mostly in the NMCs.
Yeah,
So though you have got the stringent rules now, in fact,
yeah,
not much of any other chemistry.
understood. So Martin, just to take on that NMC part, you just mentioned on the fact that when you do the testing of these cells, you force a thermal runaway on a single cell. For example, you do a nail penetration. Um, from my understanding, if you do a nail penetration on an NMC, it may explode. So how does this still pass the test if that is the case, or they do something else for the uh, forcing the thermal runaway? Something else is done.
Yes, good question, Sandith. So, yes, if we perform tests on NMC, we have to be very careful. So usually we try to keep it on a distance. If we would apply a nail penetration, then we have it done automatically and not by hand. Compared to the iron phosphates, which you have some time before the thermal runaway really gets ongoing. But the requirements are the same for both, meaning that it's maybe more difficult for NMC to pass the test than it would be for iron phosphate. Although this is not always true, because for iron phosphate, if I want to explain a bit, for iron phosphate, the problem is, or the issue is that you have a lot of heat coming from the cell and you have a lot of gases, but the cell itself cannot emit flames because there's no oxygen generated in the cell. There is oxygen bound to the phosphate, but it only releases at the very high temperatures, which are usually not reached by the thermal runaway. So fire is not coming from the cell, but there's cabling inside. You have voltage sense wires. You have maybe the wiring for the temperatures. Those ones can melt. If they melt together in a wire loom, if they melt together, you get short circuits, meaning you have highly flammable gases in your battery enclosure, and you have hot spots with high temperatures causing fires or explosion. So even for iron phosphate cells, the construction of your module, your battery, is more important than the propagation between the cells only. Now, if we look to the propagation test itself, the acceptance criteria is relatively simple. It's not allowed to have an external fire from the battery system and no battery system case rupture. The cell that we put in the thermal runaway is allowed, of course, to have fire, or if there's some damage to the battery enclosure because of the trigger cell, that is allowed, but not by the other cells. Meaning, if your enclosure is solid enough, strong enough, has maybe a venting on the output, which is also one of the requirements, so you should have one. As long as the module remains intact and the fire is not coming out of the battery enclosure, you're good to go. I mean, that's okay. That's acceptable. You have to show that you try to stop. You cannot stop the thermal runaway, the propagation from cell to cell, maybe, but then you have to keep it within the battery enclosure. And as long as it remains in the battery enclosure, it's okay. Your second challenge would then be how to get rid of all the gases, because this is also where the class societies have rules for, and they say the gases are not allowed to build up in the battery room. So you have to get rid of the gases, making sure they go out of the vessel as soon as possible.
Okay. All right. So we have this question from Harshit. That is, how do current international and national maritime regulation address battery safety? And where do you see gaps that need to be filled? So, do we have any thoughts on this from a regulation, gaps in the regulation?
Yes, I can answer this question relative simple from my experience in all the testing and all the certification processes we have done with many different manufacturers. And what we see is that there's not really a lack of regulations or requirements or things like this. The problem or the challenge often is that it's up to the manufacturers. The manufacturers has the responsibilities to perform a proper risk analysis on their product. Meaning it's being expected from a manufacturer or a producer that they fully understand the dangers, the hazards involved with their products. This can be from the product itself. This can be where the product will be used. This is which people or group of people are going to use my product. I mean, it's a big difference if your product is being used by small children or by authorized and qualified personnel somewhere on board of a vessel, maybe. That makes a difference in your risk analysis. And these are all facts you have to consider. So it's being expected from the manufacturer that they fully understand their product and also all the risks involved with the use and the application of their product. And this is what all the requirements are asking. The challenge would be that as a manufacturer, you cannot oversee all kinds of misuse that there could be applied. I always use just a little bit the how to say it, the reference to using a blender at home in your kitchen. You can still open the lid, put your hand in the blender and switch it on. It's still possible, even though the technology is far enough to make an interlock on this system that if the lid is open, the blender cannot switch on because maybe something is in it which should not be there. However, luckily as well, it's being proven that this doesn't happen. People are not doing it because they see the danger, they hear the danger, they are not doing it. So the amount of incidents happen for this is so very low that standard developers and authorities are not making a rule that there should be an interlock on the blenders. But at the moment we see an increase in incidents with blenders, then yes, we will put extra requirements in standards for manufacturers to follow. And so sometimes first an incident needs to happen before the standards are being updated. And this is unfortunately a slow process. It takes about 4 years to develop a standard, which is very slow. So we see that the industry is going much faster in developing products where there are maybe no standards for or certain risks not being addressed. That's why you have to make a declaration of conformity. All the responsibility is in the hands of the manufacturer themselves. They should be aware of their risks and do as much as reasonably can expect it on making the risk analysis.
Yeah, as they say in airline, an accident saves more lives. That's the context you were mentioning on with regards to an incident happening and the regulation following it to make it much more safer. This might be the case here. So this is the question to Srinivasji, very specific to your regulation, like all fire extinguisher methods specified in the class rules are to be compulsorily to be complied. Is there some alternative mechanism? I think that is what it is asked.
Thank you. I think definitely we can use alternative methods because, as I mentioned earlier, because the firefighting mechanism will depend to a great extent on the manufacturer recommendation, depending on the chemistry of the cell and the battery system. So
Mhm.
it is very. It is not necessary that you use a water-based system or whatever, but it is manufacturer recommendation equally stands a good value on that.
Okay. So
May I
just
add something?
yeah, please, yeah.
Very shortly, for because we also deal with a lot of class societies. There are class societies. I believe specifically Lloyd's Register. That one is only accepting water-based extinguishing methods and not gas. So there can be differences between class societies on this one. So we always read the rules from the class which is going to perform the inspection.
Yeah. Okay. So coming to this similar question, it's just a question from my side, Srinivas, regarding that small boats. You mentioned about small boats. So the space weight constraint you mentioned, right, in your presentation. Uh, as of now in India, technically, some states have adopted the application of class rules on vessels greater than 10 meter, let's say. Whereas some states still look at the 24 meter as a criteria. Given the fact that, especially inland vessels, given the fact that the economics becomes very unviable when we do the whole thing under class for the small boats, I was just thinking if there is a mechanism to ensure at least the battery side for all vessels is have some kind of an approval, not necessarily the full approval, some kind of an approval. Just like any automobiles in India, whether it is small or big, needs to have some minimum standard, so that it's a balance between the cost and safety, rather than letting any kind of battery in many of these vessels when they are small to up to 24 meter in inland. There is no practically no regulation on the battery side. So isn't that something that need to be factored in? Push instead of, if you push entire boat to be classed, then the whole economic story becomes strong. Whereas if you push the battery at least to be classed, maybe it might work. And I don't know what is in Europe in EU regulation for the smaller boats under 24 inland. But what is the thought of process of both of you? How can we overcome this, improve the safety?
No, I think you have a good point there. Because when the vessels are classed with any class, even like IRS here, so definitely our rules come into play. But if they're not classed, then there should be regulations at the inland waterways so that any battery is not just accepted as you said, because you are compromising on the safety to the cost.
Yes.
I think this is a good point. I think one of the good takeaways from this webinar, I would say, I will just discuss and we will take it forward to see how we can talk to the IWA and see what can be
Yeah.
best in there. Because safety is involved. It's very important. It's not a cost we are talking about. Safety is there. So
Yes.
definitely, I think we will take it up with the dialogue with that.
Yeah. And Martin, what about Europe? How does it work in Europe?
In Europe,
What?
we have to deal with the CE declaration of conformity, meaning that the manufacturer has to declare their product is safe. So if there's no class society being involved because maybe a small yacht or it's your own small boat and you electrify it, it means you still are responsible for the safety of your installation. There are general standards that can be applied, which are not based on the size of a vessel. So like the EN 62619 is mentioned as well, that one does not care if you place the battery in a vessel or if you place the battery in an energy storage system. It doesn't care about the size of the system. It only cares that the battery itself is safe. And there are also installation standards available which dictate you how the installation itself, where it should comply with to minimize the risks for A, fires, but B, also the electrical safety of people on board of the vessel. So if there is no standard, and this is something that we apply in Europe, but it's sometimes a bit misunderstood. If there's no specific standard for your product, it does not mean you don't need to do anything. It only means that your product is not very common, and it also means that there's no request yet about making a standard for these kinds of products. But it still means, if I look to the salt water battery, for example, yeah, there's maybe no fire hazard, but if the output is more than 15 watts, you can still cause fire with this amount of energy. So there's still a risk of applying this battery, and there can still be a risk of electrocution, or the battery might be very heavy and you have to lift it. There's a mechanical risk that it drops or it falls on your feet. So we all look from Europe. It's all based on risk analysis, and standards can help you with them, but they are voluntary and they are not mandatory.
So what you're saying is, even for the small boats, the manufacturer have to declare based on meeting certain safety standard, which is at least the minimum IEC 616 to 619 should be met, right? And so they're responsible for it.
Yes, correct.
Okay, understood. Okay, so we have another question for you from the audience, which is, what are the most common challenges encountered in battery testing for marine applications? While testing, what do you?
Yeah, as said a little bit, what we see the most is EMC and functional safety. Most parties, either they build their own BMS or they buy a BMS from the market, and this BMS from the market does not comply with functional safety requirement, meaning there's no proper risk analysis performed, there's no safety integrity level or performance level determined, and the BMS is not tested against this. So this is something which is challenging, because if you bought a BMS from your supplier and you have maybe 1,000 BMSs on stock, and you build your battery and it's already in use, and then we are going to inspect it and say your BMS is not compliant, then you have a problem, because it's not something you can fix very easily. It's not just a piece of software or an external contactor or another temperature sensor or something like this. So that is one of the challenges. Items like the propagation tests, they are becoming easier because most parties are going towards either LTO or LFP batteries. NMC is getting a bit also compared for the pricing, of course, because LFP batteries are getting very cheap at the moment. So NMC is being pushed out the market a little bit. So with the propagation test, we don't see big issues, because this is something, if it fails, you can quickly modify it and fix it. EMC is more challenging because it's not very easy to arm your product against disturbances from the outside. This requires quite some in-depth knowledge. That's for the battery testing. If it concerns how we're going to perform the test, then yes, a propagation test is always a challenge to perform in a safe way and still try to get the battery on fire, let's say. That's, of course, the goal. We want to have a nice test.
Yeah, okay. All right. Yeah. So there is this question from Gaurav Sharma. I think his question is on, will an independent surveyor from class survey the BMS and battery safety, or IRS will accept the docs from Navalt as received? I think I will answer this first before handing over to Srinivasji. So there are two kinds of boats we do, and our prime focus is on public transport, which naturally means they're all built under class. So we typically build the vessels under IRS class, and the batteries from a type approval side, and the kind of modules we take and all, it is the battery side is approved from the DNV side, the BMS, all those, and DNV and IRS being IAX class, they accept each other's class certification. Hence, in these cases, IRS accepts the certificate from the battery side, and anyway, the boat is built under IRS for rest of the thing. Then there are other category of vessels which are slightly lesser in number, which are smaller vessels, which is what I was referring or asking the question to Srinivasji. Current regulation allows the boat or the batteries to be not having any type approval. But anyway, from our side, the cells we use already have that IEC 62619, 62620, the BMS has certification. We just don't put the full type approval what we use for battery reuse for the ferries because of the cost difference and the economic demand. This will work if the regulation do not allow such a scenario, which is what I was suggesting. And if that can happen, for these, even for the small boats, so that there is no battery on any of the boats which do not meet some basic standards. This is what I hope that can be achieved, because we do a lot of things voluntary, but some of the competition can get away with based on the current regulation. Srinivas, your comment on the class approval and documents.
No, I think fully agree with you. You have given the precise answer. Yes, we do accept other class societies, but to normally, I think we are coming out. So whether we would prefer the Indian boats built in India to be classed approved by IRS, but still, when you don't have a batteries approved too many here, and since you cannot be stopping the work and going ahead, we do case to case basis approve from the other class societies. And I like, fully agree with you that we need to have some kind of systems in place that at least the minimum safety standards are maintained when the small boats, because life is life after all.
Yeah, yeah. So okay, so we have one question from Honey Baby. What are the emerging trends in battery technology for marine transportation that could enhance safety and reduce cost? It's a something, safety and cost comes are at the opposite end, where there is always a trade-off there. But the expectation is newer technologies yield or becomes less costly and more safer in many cases. So the question is, what are the new emerging trends? If any of you or both of you can come with an answer.
Well, I hope you could answer the question, let's say, as CEO from Navalt, because we are aware of course, new lithium chemistries upcoming, let's say the sodium ion ones, but they also have a risk. But also, of course, the solid state battery, for example, which should be much safer, but yet it's not really in a production way that we can all use it. And I am not aware of the costs involved in it, so I can imagine that these are very important topics. So if we have lithium, of course, is a bit unstable in that perspective, and sensitive for. Well, it's mainly the electrolyte which is causing the main problems. So vaporizing electrolyte is a bad idea and should remain in the cell itself. But maybe indeed, I think there will be other chemistries upcoming which can provide similar energy densities or higher, and also are maybe more safe. So
Yeah, I can quickly comment on both of this you mentioned, which is solid state and sodium. Both of them were there in the last Amsterdam Expo, in the electric and hybrid Expo, but their performance is still lower. It is unproven in terms of installation. So my takeaway for any of the commercial applications we look at is, what comes out in lab today, we need to think 5 years from now will reach boats. So it takes a long time for all this test and ensure it is starts with maybe in automobile industry, get some vehicles out, get the lessons out, and until it starts in marine. So even today we are not foreseeing any change to the current lithium chemistries, which is our preference of LFP LTO for the next 4 to 5 years, because I don't see any new one that has come out which has better than the current system. It's just my observation, but yeah. Yes. Okay, so yeah, there is one question to Martin. That is, what are the most critical battery safety parameters that testing should focus on, and why?
yeah, I think I answered some of them already. Of course, what we see in every test need to be performed on lithium batteries. The requirement is always similar: no venting, no fire, no explosion. So those are the most safety parameters. And as said, these tests are easy to perform, and you can quickly see the results. So those are not the challenge. The main challenge is in the battery construction itself. Is your wiring up to all the currents that are running? How about your fuses? Did you take into account the short circuit currents that could run. Because if you short circuit the cell, very, very high currents can run through your system. And is your fuse capable of handling this? And if we look on a system level, it becomes even more complex because we have contactors, we have circuit breakers, and we have fuses, we have manual service disconnects. You have to take that in account. You have to be careful that at the moment something goes wrong and there's a very high short circuit current running through your system, that your contactors are not trying to act as circuit breakers. So you have to be sure circuit breakers are doing their job properly and being used in the right way. So it's very critical to look at your components and what are the specifications of each component, and do I use it and apply it in the correct way, and that you are not misusing your component. It can be as simple as a contactor. Some of them have a plus and a minus. It's a switch, but there's a plus and a minus on it. You have to connect it in the right order and not reversed to avoid problems with your contactors, like sticking relays or something that could occur. So this is, I think this is this is very underestimated. It's a simple standard from the outside, but if you look really in the details, there's a lot to take in account. It's not just the few tests are just to verify your product is okay, but it starts with the evaluation of every component and your design. What do you want to achieve with it? What's going to happen in your battery? How are the currents and voltages are going to flow? What about unbalanced cells, etc.? You have to take this in account. The testing itself is the easy part.
Yeah. Okay. Yeah. So there is a question for Srinivasji. I do not have a type approved battery system. Must be from a boat yard or a boat owner. But a manufacturer is ready to conduct required test. Is it acceptable?
Definitely. So, because having a type approval is required, but still, when what is the ultimate objective is to ensure that it is safe, battery is safe to use. So, when there is a testing can be done, definitely it can be done. It will be project specific for the particular project. Like when you do type approval, it can you keep on using it for any ship, but in this case, it will be project specific. But it can be accepted, not an issue.
Yeah. No, I just want to cite one incident where the unit approval has had issues without naming the project, where the unit approval battery has, because of the failure in the cooling system, the battery has failed, and now they're forced to replace the battery in 3 years. So this is also a challenge when so type approval guarantees a lot more things beyond a mere unit approval, is what I think, because some things are presumed that the manufacturing process is taken care, etc., which may not be the case in unit approval. Is just my submission, considering a failure in one of the electric boat in India itself, which probably IRS can dig out the incident, but this is just an observation I just want to make. There is a question from Ravindranath Adi Batla on what is the life cycle of battery. It is obviously, if any of you can go ahead, or I can also tell. So yeah,
It's a lot. So we have in Europe, we have a new battery regulation, and this regulation forces manufacturers and producers to also look to the origin of all the materials being used in a battery as well. This is also part of the life cycle, because all these materials are either gained somewhere, are being transported, causing carbon, adding to the carbon footprint that we have, and it should be reduced. So this is something you have to take into account in the whole life cycle assessment of your battery. Where are the materials coming from? Which area? How is the situation there? Is it are the materials, is the country, let's say, stable, or is it in a war? Yes or no? How about the carbon footprint, etc.? It already starts over there. Then you have the transport of the cells. If the cells are produced, you have to transport towards the country where you are, or to the assembly line. You have to take into account the assembly line of making a battery as well. And there are many factors involved. Even there, we have to deal with people around it, etc. And then you have the usage of the battery itself. So yes, you can cycle it maybe a few hundred times, maybe up to 10,000 of times, like LTO is stating. And then at some point, the state of health, meaning the capacity left compared to the original capacity of the battery, drops below a certain percentage. It normally used to be 80%. Nowadays, you can still safely use a battery up to almost 60% state of health. But from there, the battery is going to degrade very fast. You get a lot of dendrites forming inside the battery, which are very small metal parts, and they can penetrate through the separator, causing small hotspots, and you lose capacity over there. And this is becoming worse and worse. So at some point, the battery is not good enough anymore, and the risks are of the battery breaking down, but also maybe causing thermal runaways or venting events, is also getting bigger and bigger. And then you have to dispose the battery. It has to be recycled, or they have to do something with it. And at the moment, it's being collected and placed to battery recycler factories. And from that point, they have to either recycle the black mass, take it out, which is very time consuming, and it's expensive at the moment to do so. These are also factors you have to take in account on the whole life cycle of a battery. So I hope this answers a little bit the question.
This also had answered the other question from Mr. Koshi Samuel on the disposal process also, which, if I may add, the manufacturers are now bound to take back the batteries, and that is included in the cost. At least in Europe, it's very clearly the regulations are in place, and especially when we take the modules from there, that is anyway being followed. Now, regarding the life cycle, I just want to comment. If it is meant the number of cycles, then it's obviously dependent on the battery chemistry, and like the LFPs we use typically around 3,500 cycles, which last up to 7 years on 1 to 2 charging per day. So this is like, and it achieves as 80%, and the LTO is 10 years, 32,000 cycles. This is the ones we use. And typically this achieves an 80% state of health, and then you can shift it to a land-based energy storage for another 5 to 7 years, like when it reaches at 50-60%, and then you have to look at recycling. So it's a 10 to 15 years period what we are looking at, and then recycle. This might be the process, of which current lithium technology recycling is 90% you can extract, and that is increasing as we are working on newer and newer technology for recycling. So let's go to the next question. Yeah, sure.
Yeah, so I just want to get back to this point which you mentioned. So Mr. Martin also mentioned about if we can recycle the battery and use it again. So I just want, so basically from a business development or from a owner perspective, which will be economically beneficial if we are recycling my own battery. So let's say assume I have used 80% of, or my associates right now 80%. Then is it economically beneficial for me to recycle the battery or procure a new battery, assuming that I'm procuring battery right now and 7 years down the line I'm going to change it?
So the issue is in transport system. Once you reach 80%, technically your operations start getting affected, unless you are built into that at the time of design, that you are assuming that 80% still works is what you do in the design. Otherwise, once the operations start affecting, then obviously you don't have a choice in continuing with the current battery, and thereby you move it out of the boat and replace it. What you do with that battery is up to you, whether you have a choice of selling it to some energy storage company or who then may then recycle after their use. This is I think this might be the case.
In Europe, we also have some political decisions making it also more difficult, because most cells, of course, are being produced in China, and China really likes to have lithium iron phosphate back. But if we have used them, you cannot ship them back to China. That's very problematic. We have lots of regulations preventing this, let's say, from happening. So we should collaborate more together, I would say, let's say, between the manufacturers, all the cell manufacturers, because we don't know what to do, and the recycling costs are very high. We don't know what to do with the iron phosphate cells, and China wants them back. And we have regulations saying you cannot simply send them back to them. So it's also some political decisions that has to be made to make also the disposal, but also the recycling or the refurbishment much easier as well.
Yeah. Okay. Okay. All right. Yeah. We
And
have.
Sandith, I think
Yeah.
just to when I look back to both your conversations, so when you talk about battery life, I think we need to look at two things. We could summarize that one is cycle life and one is the calendar life or life of the battery. Where
Mm.
Mr. Martin says it starts from the procurement of component itself, not only when the battery module is made. So it starts from there. One is a cycle life. So that's how
Yeah.
you have to treat the batteries.
Sure. Yeah. Yes. Sure. And Srinivasji, this question is for you. Can you tell about the different class have different regulations and guidelines? So is there any effort in aligning them just like the uniform for the tankers and bulkers and other vessels, right? You have the. Is there any effort in this battery side as well?
It is there, just like Mr. Martin has just said. He give an example of Lloyd's asking for a particular type of fire extinguisher system. So this is there between the class societies. Obviously, maybe because of their own experiences of the rules. But now we have a new panel called Saved Decarbonization Panel in the AX, where the project team is working on this energy storage systems. One of them is the battery. So they started with the battery system itself, where you'll be having a unified requirements across all the class societies. It is on the process of development now.
Okay. 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 So we have a bit broad question, which I don't know if you can answer. Like, what are the major challenges and opportunities in adoption of battery technology in the marine industry? This is from an adoption point of view and how to ensure the electrification of marine transport. I think that is what is the question asked. Your thoughts?
You ask me.
Anyone can go ahead.
No,
Maybe
for me, I mean, I think yeah, you are the better place. But anyway, it is more of the business. Like I think you're the best person to answer. But since you asked me, I will tell. It is more of the business because what kind of batteries and capacities. Finally, it is economics. It has to work out. At the end of the day, it is about economics works out while keeping the safety in the mind. So by choosing the correct battery and making sure that it is properly tested and do optimum sizing of the battery. This is very important. Not that we should cut down, but it will optimize. So when you optimize, you're saving a lot of things. The costing and the associated other auxiliaries, auxiliary systems, everything is associated, including the short charging facilities, everything. So I think that's what the long run. Finally, the charterer will look at or operator will look at the cost, how much you are spending for that. So that's what I think. I think now you can elaborate further, Mr. Sandith.
yeah. So Martin, in Europe, this is where the maximum electrification happens in the marine transport. So the question, the intended for India is something what Europe has already addressed in some way. So do you want to tell something on this?
I think that opens a great opportunities, of course, because we have regulations in force which are, requiring, for example, all the boats in Amsterdam to be electrified, meaning there's a big market for it. So that is a very good opportunity. And the major challenge is to find your way through all the rules and regulations that we have, and to get the product properly and safe installed in a vessel. That is your major challenge.
Mm-hmm. Okay. Okay. So this is a very specific question. I think Martin wanted to ask Srinivas. So this is regarding if there is an ESTRIN approval, if class also accept test results and when there was no witnessing from themselves, or if there is a witness from another class.
Okay, because they also accept results from. No,
Yeah. So
we do accept it. I mean, two occasions we accept. One is if the tests are witnessed by any other A class society, we do accept it. And if they are done in some accredited laboratory, like a government accredited laboratory, we accept it, even though we were not physically present. But now, normally we would like to be present, but in a certain, sometimes it may happen that few tests are done before, which we don't, or we don't want to repeat because of cost and time. Yes, we do that.
Okay. Okay. Clear.
Yeah. Okay. So there is one to Martin. That is one of the most significant advances in battery testing methodologies that have emerged recently.
Yeah, and the significant advancements in battery testing methodologies. I think most important what happens in the biggest change, especially in Europe, is the new battery regulation, which not only looks to the safety of the batteries, but through the whole life cycle. Meaning you have to do much more, also by the carbon footprints, also by the recycling or the refurbishment of batteries. You need a battery passport. Standards are being developed to give guidance on how to deal with these requirements, because otherwise you have to think about it yourself. And also another aspect which is coming more and more is the functional safety aspect is becoming more and more important, because there's not really a safety standard for a BMS yet, but it's a very safety critical component. So, and there's no specific group, let's say, or a committee who wants to take the responsibility of making a standard to cover requirements for BMSs.
Okay. Okay. So I think this might be the last question. So, and I want both of you to try to answer. That is like, how do you envision the future of battery safety in marine transport, and what role will technology play in it?
I think as the technology is definitely improving, not only from the making the smaller, lesser weight, and also from the safety point of view, we will have more safe battery systems.
Okay.
That was, I think, will come, and which will help most of the companies to go for this batteries per power system. And obviously, the costing has to come down, because that's one of the factors. I think the cost is also quite high now. And testing facilities. So we have one which Mr. Martin can answer, but I can see that they are improving. They definitely will come into a larger price.
Okay.
Yes, I
So Martin,
agree on
you
that.
want to take this question, the key recommendation for policymakers and industry stakeholders to accelerate the safe and widespread adoption of battery systems in marine vehicle?
Yeah, well, in that perspective, I think we don't need to wait or look at the policymakers, but mainly on the industry stakeholders, because the standards, specifically in Europe, are being made by the industry and not by the policymakers. The policymakers, they set targets to achieve, and they ask the industry stakeholders, which are in the safety committee, how can the rest of the industry meet these targets in a good way. So I think in the past it was different. So in the past, before 1985, the policymakers, people behind the desk, they were also making the requirements. But they are not really that involved as the industry, because the industry knows better. So they turn it around and they said, okay, industry, you go ahead, make safety standards. We only need a safe product, and you have to tell then the rest how to achieve this. And you have to create how to say it, a free field, let's say, or let's say a common field where everybody does it in the same way. That would be the best. So we all have the same chances to sell our products on the market. But I think the key recommendation for policymakers, they already have it, and they point towards the manufacturers and the producers. And I think they have to maybe stipulate a bit more on their responsibilities. And what the policymakers could do is try, but it's not easy, try to make it a little bit more easy to find your way in all the regulations and standards that we have. But it's not easy, because even on our side, sometimes we are faced with a certain standard that I was not aware of, even though I'm a chairman of battery committees and I join on IEC level as well. So I'm involved in quite some committees, and even then there's somewhere an ISO standard hidden that says something about, and that's very difficult to keep track of.
Yeah. Srinivasji, your thoughts in this? Because you're part of a lot of policy committees.
No, the present, at least when I can talk from Indian context, the present government drive towards making zero carbon emissions and going using green fuels already has started, initiated this process of, and of all the green fuels, I think batteries for the small boats are the best bet. So they definitely, and one point you suggested in the beginning is to have a kind of regulation for the small boats where we may ensure that only certified batteries are having a minimum set of standards are to be kept. I think that is a good policy to begin with, so that already there is a government is directed to go for more and more
Yeah.
boats, battery boats that already started now, and definitely this will add up to ensure that all the batteries not only they are used but they are safe to use also.
Yeah. I just want to highlight two things. What is at least my expectation from the government, Martin? When you say industry is taking the lead there is something that is already there in Europe, which is missing to a large extent in India, which is there's a lot of financial support for the adoption of electric. That is the only thing that the government needs to do. Like the system in EU grants where 40-50% of the project is financed. There is no equivalent system in the boating in India. There is in the electric vehicles under the FAME scheme. There is no clear equivalence in the boating. There was a one closest policy that announced in October last year is for the shipbuilding subsidy to extend to smaller solar boats as well, which is decent. And there's a slight higher subsidy for solar electric boats and other green technology boats compared to others. That handholding required for the first initial years, which in parallel ensuring the standards both has to go together, is something that is important. What government can play a role. The second thing what government can do is what you mentioned about Amsterdam, where they have identified an area and ensure that nobody can put an alternate system in place, so that automatically everyone has to follow the electric boating. And so we need to identify such potential in India, for example the lakes, the dam sites and areas, other eco-sensitive area, mandate, and then anybody can come up with the technology exists. It just, these are the two things that government can easily do to support the
Yes.
wider adoption of electric boating, is what I would say. Yeah.
Yep.
Okay,
Yep, I
so
agree.
we are already past our intended time. So over to you, Ajay.
Yes, sir. And I think, like I mentioned, time is the villain here. We can't do anything. And all of us would agree to that. And I think still we have a lot of pending questions. I'm really sorry, but we are running out of time. But next time, we will definitely get back to you. For this time, I think a wonderful session and a very informative from all of you guys, and also a lot of good questions from the audience as well. So, thank you, everyone, for coming in and joining section. Thank you, the panelists, for getting us the informations, getting us the industry inside, and the also expert opinions about the battery safety. So this was the first episode of our webinar deep dive. We will be coming back to you with more such topics which are relevant in this industry. And like we say in India, we never say goodbye. So until we meet next time, thank you so much. This is Ajay signing off from Deep Dive. Thank
Thank
you.
you.
Jai.
Thank you.
Thank you,
Thank
Ajay.
you.
Thank you, Sandith. Thank you, Mr. Martin.
Thank you.
Thank you,
Bye.
guys.